right, here I'll be explaining to you how you can construct a parabola using a locus method, and this is the question that you want to use. As the question says that construct a parabola using locus method which has its vertex 20 millimeters from directrix. So the distance between the vertex and directrix is 20 millimeters. So let's go and see how you can construct the parabola using the locus method as we are instructed. So what we need to do now is to draw a horizontal center line like this. All right, so then the next thing to do is to draw a vertical line, okay, so of any length, so you don't have to be worrying about the measurements, so of any length. So I'm okay with this distance. So I will call this point, I will call it point A. I will call this point, I will call it point B, and I will call this point here where they intersect, I'll call it point C, and then maybe I should just put D somewhere here. So we have so this line AB is the directrix. This line AB is the directrix, and line CD is known as axis. So don't forget that I said they don't have any measurement. You don't have to worry about the measurement of that. So now, very important, the next thing that we are going to do, as we are told in the question, that the distance between the directrix and the vertex is 20 millimeters. So I will take a measurement of 20 millimeters from this point C on directrix forward. So this is 20 millimeters. So this point is where we have the vertex. So vertex is denoted with capital letter V. Okay. Now we need to locate a point known as focus. I said we need to locate a point known as focus. And when it comes to parabola, the eccentricity of parabola is equal to 1. The eccentricity of a parabola is equal to 1. So as a result of that, this distance CV, which is 20 millimeters, will also be the same as distance VF. I mean, this is the distance VC. So we also be same as distance VF. Distance VF is the distance between the focus and the vertex, or the distance between the vertex and the focus. So because the eccentricity of a parabola is equal to 1, meaning that if I divide VF by VC, the answer will be 1. That is 20 divided by 20 will give me 1. So that makes us to have that the eccentricity of a parabola is 1 millimeter, is 1. So I have to take a measurement of 20 millimeters from here. Okay. So here I have F here. This is point F. That is the focus. So this is F, focus. Okay, so now the next thing that we are going to do, having located these distances, so I'm going to draw perpendiculars on this axis from V. So I will take 10 millimeters. So this is 10 millimeters. Since this is 20, so that's 10 millimeters. So then we already have this to be 10 millimeters. So I'll just take 10 millimeters again. So this is under 10 millimeters. So this is 1, 2, 3, 4. So this is 5. So 6 is okay for me. I will just manage 6. So 6 is okay. So all right, so the next thing I'm going to do, I'm going to number this point. So this is 1. So this is 2 on the focus. We have 2 on the focus. So this is 3. So this is 4. This is 5, and this is 6. Okay, so I'm going to erect perpendicular on each of these points. So this is it. So I'll draw a perpendicular line like this. So here I will also draw a perpendicular line. I also draw a perpendicular line here. So at 4, I will draw a perpendicular line. At 5, I will also draw a perpendicular line, and at 6, I will also draw a perpendicular line. All right, so having done this, the next thing that we are going to do is to take our compass. So I need to take my compass. All right, so now, so I have my compass with me. So you put the pinpoint at point C here, and you take distance C1. C1, then you raise it up like this. So put it at the focus. Put it at the focus. So take it easy, and you make an arc on the on line 1, up and down like this. Okay, then you go back to point C on directrix. You extend it to 2. So 2 is on the focus. So just extend it to point 2 here. Then you raise it up, put it at F again. So you make an arc here and make an arc here, up and down the line. Then from C to 3. From C to 3. So put it at F, make an arc on line 3. So up and down. Then next is from C to 4. From C to 4. So put it at F. So make an arc up and down the line. Then from C to 5. Then put it at F. So make an arc up and down line 5. Okay, so this is okay. I don't have to put that of 6 there. So then the point of intersection of the arc and the line need to be taken note of. That's what I'm doing now. So we also have a point here. So we have a point here, a point here, here, and here. All right, so the next thing I'm going to do is to join this point together with the use of a French curve. So, and everything we meet at the vertex. So this is it. Okay. Okay. All right, so I've joined those ones together. So the next thing I'm going to do here is to join these ones together, and they will all meet at the vertex. Okay. All right, in addition to what we have done so far, so I'm going to show you how you can construct a tangent to this parabola. So how can we do that? What you need to do, so to a point, we have a point here. So this is the point that you want to put the tangent on. So we have point P here. So what you need to do now is to join PF together. Join PF together. It's a straight line. So this is it. All right, so the next thing that we are going to do is that we are going to draw a line that will be at a right angle to line PF. So I will set my protractor on this line. Set my protractor on this line. So at 90, so that line 90 is very, very important. So I just put a dot here. Okay, I put a dot here. So then I'm going to draw a line. I'm going to draw a line from F. So from F, so I just need the point So the line that I want to draw will just stop on these directories. So I'm just using this point to get that point, to get that point on the line. So I will draw a line like this. So this point, I will call it point Q. Okay. So this line, line PF and line QF, they are at right angle to each other. So this angle is 90 degree. Okay. The next thing I'm going to do is that, so I will put the, I will set my, okay. So I'm going to draw a line from Q passing through point F, and that will be the tangent. So this is it. All right. So this line is the tangent. So, and then I want to draw a normal to this point, to point P. So we need to draw a normal to it. So I'll just set my protractor on point P like this. So set it on P like this. Okay, so at 90, so I just put a dot here. Just put a dot, okay, on that 90. So now I'm going to draw a line. So from that point, so passing through P. So I don't have to make it long. So I'll just draw from here to here. Okay, so that line is a normal, so I can extend it. Okay, so this line, so let me call it line RS. So this is R and this is S. So line RS is a normal to the tangent. Okay, so QT is the tangent. So this is how you can construct a tangent to a parabola. So thank you and keep on practicing.